Limits in lambda. Limits are a very important and fundamental element in infinitesimal analysis. This mathematical element has a structure that consists of the textual writing of lim, the variable with respect to which the limit is calculated, the value to which the variable tends, the function on which the limit is applied. Generally, this function, as you see below, x to the second plus 3, is written in parentheses, to avoid ambiguity. For example, in the writing above, it could be the limit only of the function x to the second, and then the plus 3 could be a later operation. Generally, however, there is no such ambiguity, and sometimes the parenthesis is avoided. In any case, this is to say that even in lambda, the limit structure is closed before the function, because the function must be inserted in brackets, if it is to be shown that it consists of several elements. But let us take a closer look at how the limit is inserted in lambda. It is particularly simple, because all you have to do is type the letters L, I, M directly from the keyboard, and it is automatically recognized by the system as the opening of the element limit. In fact, it appears in red, like all openings. Even when moving with the cursor, it is taken as 1. And even in the status bar we find the writing limit opening. Once open, being red, one expects at the very least a closure, or separators. We enter the variable, which may be for example x, or x with 0, or t, or even an expression. Once the variable is written, a separator is inserted with the control key plus I, which is described in the status bar as separator in the limit structure, and on the screen appears as an arrow, which is what is expected. Then the number must be entered, the value to which x tends. Let us assume that this number, for example 4, is a right-hand boundary. We can safely insert a superscript with the plus symbol to say that it was a right-hand boundary. At this point, x tends to 4. We have closed the limit structure. How do we close it? We close it with Ctrl plus K. Below, we can enter the function with or without parentheses. To avoid ambiguity, we also put in the parenthesis. We do, for example, x to the second minus 1. Later we will calculate it. We check with F4 that it is exactly what is expected. Here it is, limit, x tending, arrow 4, from the right. So the limit structure ends here, then continues, eventually, the function. It is interesting, then, to be able to manipulate with the classic Ctrl plus D, which makes it possible to duplicate all the writing, which is not quite so easy, and eventually work only on the expression, which sometimes needs to be simplified, or collected or factorized. It is often necessary to use the infinity symbol when calculating limits. The symbol infinity is not typed with a key directly on the keyboard, but must be searched for within the symbols, which we can find here in the special symbols. Here it is, infinity. Alternatively, I recommend when tackling infinitesimal analysis, to create a special profile, in which you assign the symbol for infinity to a keyboard key, in order to speed up the operation. Or alternatively, once you have entered it, also from the menu, you can then copy and paste it where you need it. The copy-paste operation is not always fast, so it is better to use a specially assigned keyboard key in a profile.